For today, we are looking at this radical expression from 2017 Singapore Math Olympiad Junior. We are asked to find the value for this expression. After we solve this, I'll talk a little bit about Ramanujan infinite nested radical.
Pause the video now if you wish to solve it. Keep watching the video once ready.
In order to solve this question, we just need to use one expression that all high school students should be familiar with. That is, square of n plus 1 equals to n squared plus 2n plus 1. Now in this case, I'll write as 1 plus n plus 2. And if we take a positive square root, then n plus 1 will be equal to square root of 1 plus n plus 2, if n plus 1 is positive. So with this, when we look at this one, square root 1 plus 2013 times 2011, we can recognize that this is actually of this form, that is 1 plus n equals to 2011 times n plus 2. Then the result will be n plus 1, that is 2012. So we need to bear in mind that this square root equals to 2012. Next, we look at the next square root, that is a square root of 1 plus 2014 times 2012. So square root of 1 plus 2014 times 2012. Square root of 1 plus n times n plus 2 will be equal to n plus 1. In this case, n plus 1 equals to 2013. And we will proceed and say that this is 2013. And we do the similar thing, the whole thing for the third square root inside, it will be equals to 2014. Then this will be 2015. And therefore the answer for this will be equals to 2016. We just need to use this formula again and again. Now, I'll extend this question a little bit, and we do not stop at 2011. We'll keep moving. Let's say this is square root of 1 plus 2017, square root of 1 plus 2016, square root of 1 plus 2015, and so on and so forth until square root of 1 plus 3 times 1. So if we keep using this formula, we'll see that this exactly will have the same answer as 2016. Next, I'll discuss a little bit of Ramanujan infinite nested radical. If you enjoyed this video, please like, comment, and subscribe. Square root of 1 plus 2, square root of 1 plus 3, square root of 1 plus 4, square root of 1 plus 5, square root of 1 plus 6, and so on and so forth until infinity. What will be the answer? To answer this, we can use the formula that we have just now. N plus 1 square equals to n squared plus 2n plus 1 and equals to 1 plus n plus 2. So n plus 1 will equal to square root of 1 plus n plus 2 if n plus 1 is positive. And it is a little bit different from what you have just now. It's because the previous question, there's a stop somewhere. For this, the process will keep continue. And actually, the first question we should ask whether this radical has a solution. So people claim that yes, it has a solution by just looking at this. So this is 1 plus n. We can replace n plus 2 by saying that n now is equal to n plus 1. So this will be equal to square root of 1 plus n plus 1 n plus 3. After this, We copy down square root of 1 plus n, square root of 1 plus n plus 1. And for n plus 3, we keep using this formula again and letting n now become n plus 2. So this will be equal to square root of 1 plus n plus 2 and n plus 4. Now you can see the pattern. It keep continue and it will be 1 plus n, square root of 1 plus n plus 1, square root of 1 plus n plus 2, and square root of 1 plus n plus 3, the square root of 1 plus n plus 4, and square root of dot 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 means that it will keep continue. So in order to get the value here, we just need to sub in n equals to 2. So this will be 1 plus 2, square root 1 plus 3, square root 1 plus 4, and so on and so forth. And the answer will be equals to n equals to 2. So the answer here is equals to 3. This is one possible explanation of why this radical equals to 3. But using this method, people claim that it is not that rigorous. That is because we don't even know that whether the radical itself exists. Example, let's say x to power x to power x to power x, power infinite many times, and it is equals to 4. What will be the answer of x? Some people claim that this itself also equals to 4. So x power 4 equals to 4. So x will equal to 4 to the power of 1 over 4. It looks reasonable, but actually this is not true. You may look at some of my explanation in the description. When we deal with infinity, we need to be a little bit more careful, because many properties that we enjoy in finite system may not be the same as in infinite system. That's all for today's lesson. I'll see you again next time. Bye bye.